Okay, so here are some of the work and explanations for the unit 2.10. This first part is already written out pretty well, the definitions. The second part, though, is where it gets into signal to noise ratio. And the idea is that signal to noise ratio is the signal level in decibels minus the noise level in decibels. So in this question, number one, if the level of normal conversation is 60 dB, that would be the signal level, and the background noise levels are 40 dB, then what is the signal to noise ratio? So the signal to noise ratio then would be the difference between the signal or speech level and the background noise level. So that would give you 20 decibels. Okay, this next one takes into account the information in the table about speech intelligibility. So this requirement to produce 0% speech intelligibility, okay, from the table in the book or the notes, okay, that requirement for 0% speech intelligibility means that the signal to noise ratio needs to be minus 12 dB, greater than or equal to 12 decibels. Okay, so here the original signal is 75 decibels. Then there is a door that is going to attenuate, okay, a special sound rated door that's going to attenuate that by 30 decibels. So that means that the sound leaking into the hallway or the foyer is 45 decibels. And then the question is, how loud does the noise? So that's what we're calling the signal level in the foyer. Okay. And then the question is, what should the added background noise level be? To get 0% intelligibility, which is a minus 12 dB signal to noise ratio. So if we go to the signal to noise ratio formula as the signal level minus the noise level, we can solve that, rearrange our equation, and get that the noise level is equal to the signal level minus the SNR, the signal to noise ratio. So the noise level that's needed is going to be that 45 dB signal that reaches the foyer minus a negative 12 decibels, which turns into a positive. And so that's 45 plus 12, which is 57 decibels. Okay, so now with the filters and figuring out speech intelligibility according to the filters, the really important thing to remember is that low pass frequency filters, low pass filters, pass sounds or frequencies less than the low pass filter cutoff frequency. So all of these guys. Okay. Whereas the high pass filters pass frequencies greater than the high pass filter cutoff. So everything this way of the cutoff frequency. So that would be the high pass filter cutoff, and this would be the low pass filter cutoff. Okay. Now, when those are combined, done sequentially, essentially, then you get what would be called a band pass filter. And in that case, the low pass filter passes everything below a certain frequency, and the high pass filter passes all of those frequencies that are above a certain frequency. Okay, and that would be then the band pass. So the band pass passes frequencies between the high pass filter cutoff and the low pass filter cutoff. Okay. Now this table here, this is telling you about the intelligibility of speech after it's been passed through different filters. Okay, so this is our, try to keep my same colors a little, this is our low passed column. If I pass something with a low pass frequency cutoff of 100 hertz, it would be 0% intelligible. If it was 1,000 hertz, then it would be 26% intelligible. That's what that means. And this other column is for high pass speech. If I passed everything above 100 hertz, then I would have 98% speech intelligibility. Everything above 1,000 hertz, that would be reduced down to 89% speech intelligibility. All right. So we're asked, what is the speech intelligibility score here in number 3 of a sound that's gone through a high pass filter with cutoff frequency of 500 hertz? Okay, so we're dealing with high pass filters. So I got my green marker. I'm doing 500 hertz, high pass column, okay, gives me 96% speech intelligibility. Okay. But then this next one, we're going to do a band pass. Okay, so I will do this one in orange. I'm going to do it up here where I have more room to write. Speech intelligibility score. So my band pass frequency, my band pass filter is going from 500 to 3,000 hertz. Now, the most trickiest thing is to identify which of those frequencies goes with the low pass and which goes with the high pass. So the higher of the frequencies in the band pass is the cutoff for the low pass filter because it's passing things below 3,000 hertz. And the lower frequency in the band pass is the high pass filter because it's passing things above 500 hertz. So 500 hertz high pass filter, that's our 96% we already have marked here on our chart. Okay. So that if you high pass filter the sound with the 500 hertz cutoff, you would get 96% speech intelligibility. And then if we come over here to our chart and find 3,000, do the low pass column, okay, then we have 88% speech intelligibility if we just low pass filtered it. But we've done both. We've high pass filtered, which reduced intelligibility to 96%, and then only 88% of the 96% it will be the speech intelligibility. So to find the overall intelligibility score, okay, then you take, and you have to convert these guys to decimals from percentages. And you do that by moving your decimal place 2 points to the right, dividing by 100. Okay. So then the intelligibility score is going to be 0.96 times 0.88. And then to get it back to a percentage, you would multiply it by 100. Okay. And that is how you would put that in your calculator and you would calculate. Let's see what it is. .96 times 0.88 times 100 would give us 84.5% speech intelligibility. But again, here I just wrote it out in numbers. No, there it is, 84%. Don't worry about the 0.5 right now. Okay, so we're going to do the same thing again here on number 5. Okay. The band pass filter itself, this, okay, as a function of frequency and the response, or what it multiplies the signal by. And we have 2 frequencies here. We have the 100,000 hertz the 2000 hertz. And we have to make sure we carefully identify, right, that we passed frequencies below 2000 hertz. So that is the low pass frequency cutoff. And we passed frequencies above 1000 hertz. So that is the high pass frequency, high pass filter cutoff frequency. So now we have to go back up to our table, say 1000 hertz in the high pass filter. So here I am. I'm going to use purple this time. 1000 hertz. So that gives me an 89%. So that's 89% speech intelligibility. And then the low pass filter of 2000 hertz will give me 70% speech intelligibility. Okay, so the band pass filter intelligibility is equal to the high pass filter intelligibility converted to a decimal place, which is converting to a decimal by dividing by 100, times the low pass filter, 70%. So you can think of it as the sound goes through the high pass filter, which reduces the intelligibility by 89% of the original. And then that 89% gets passed through the low pass filter, which reduces it 70% more. And then you multiply it by 100 to get it back to a percentage. So we have 0.7 times 0.9 times 100. And it doesn't matter which order you multiply these in, either way is the same. Okay, hope that made sense and helps out.